Good morning, good afternoon, and good evening. Hope that you are all doing well and staying safe. Here is Mariam Shref, a senior petroleum engineering student at the Lebanese American University. Welcome to the second lecture of our online course, Introduction to Python Programming, presented by a special guest speaker, Dr. Abdelrahman Kotb. Dr. Kotb is a lecturer at the William Michael Barnes Department of Industrial and Systems Engineering at Texas A&M University. His research interests include building calibrated machine learning models that predict physical phenomena, studying reaction kinetics for wellbore stimulation, and CFD modeling. He has authored and co-authored 8 publications. Moreover, he holds a PhD degree in petroleum engineering from Texas A&M University. Finally, Dr. Kutb serves as a reviewer for SPE Journal. So please help me in welcoming Dr. Kutb. So welcome, Doctor, and we are pleasure to have you with us today. And on a final note, if you have any question related to the technical content of the presentation, please feel free to drop it down in the Q&A section. Now, without any further ado, Dr. Kutb, the mic is yours.
Good morning, everyone. I hope everyone's doing fine. I'm happy to be here again. I just want to comment on a question that I received is whether or not I can share my lecture examples, and of course I can share them. I will talk to Mariam after the lecture to see what we can do about that. The second thing I want to say is for the command prompt, some people discussed last time that they could not see what I was writing, so I made it larger, so hopefully this time things are clearer and more obvious for everyone. So today we're going to talk about the second lecture. So this is what this is the schedule, and I actually expanded data structures to 2 parts, and I'm gonna say why. Last time we discussed getting started, chapters 1 to 5 in the book, and pretty much it's installing Python. What can we do with Python, and why is Python important? Today and the beginning of next time, I'm going to talk about data structures that include lists, dictionaries, tuples, and actually because I realized this is such an important topic, I decided to split it into some of it this time and some of it for the next time. So next time we're gonna talk about dictionaries, tuples. However, our main focus today is going to be lists. So we're going to discuss, if you're following through the book, you would today we're going to discuss chapters 6, 7, and 8. So these are the topics that we're going to talk about today, which are strings, files, and lists. And let's start with strings. So strings is a type, so we can say name is equal, anything in quotations is a string by Python's definitions. And as I mentioned last time, it can be either a single quotation or a double quotation. I also mentioned that whenever you are naming a variable in Python, the the capitalization of the wording is actually significant for Python. So for example, name all small letters versus name all caps, or even one capital letter in the naming becomes completely different. So let's say last time we talked about adding or multiplication of different integers and float numbers, and we realized, okay, Python understands when we have a number and we're trying to add it, multiply it, divide it, Python knows what it does. So 2 plus 2 is 4, 6 times 5 is 30, and so on. However, when it comes to a string, it might not be as intuitive because we are adding words to each other. So what Python does when we add 2 strings to each other, it pretty much combines it. So my name, if you name another variable, which is together equal name plus name2, and you print together, it's going to give you my name. If you try and add a string to a number, Python will not be able to understand it, because for Python, these are 2 completely different things. So I'm just gonna pause for a second. I think there is a yes. I had a virtual background that I think was fading my hand. So using input makes the user enter a string. So I think we talked about this. We talked about this last time a little bit. Whenever we ask the user to enter something, Python takes it as a string. If we then want to convert it to something else, we have to do that within Python. But whenever we ask the user for something, Python takes it as a string. So let me give you an example. So hopefully everyone can see this. So if I open Python and let's write this example. So I have name is equal my. I'm gonna make it double quotations, and name two. Actually, name two is equal name, and then together is equal name plus name two. Print together, and so what if I want to add a space in the middle? In that case, I would have to come here and say plus space plus name. And this way, I say print together. I get my. So for Python, Python doesn't really care whether this is a one word, two words, letters. It just does what you're asking Python to do. So name plus space plus name underscore two would just give you, okay, Python knows, okay, I'm adding this first string, which is you refer it as name, and then the second string, which is a space that you decided to add, and then the third string, which is name underscore two, which is another string. So now I want to look inside a string, and this is actually very important and very useful whenever you have thousands and even millions or hundreds of millions of words, and you're trying to look within these words, looking for a specific word, specific meaning, specific sentence. Indexing becomes very important. So for example, if we have a word like banana, Python has an indexing strategy, indexing method, or zero indexing, meaning that whenever Python starts counting, it starts from zero, except for length, which is a bit counterintuitive. So let's say I write banana, B-A-N-A-N-A. So how many letters? 1, 2, 3, 4, 5, 6. If I ask Python what is the length of banana, Python is going to give me 6. However, if I ask Python to give me the 6th letter of banana, so 6, it's gonna tell me that it's outside the index, and I'm actually gonna show you. Right. So if you have X or fruit equal quotations, banana. Okay. So length fruit 6. Down 1, 2, 3, 4, 5, 6. So we have 6 letters. If I want to get a specific letter of banana, I can say fruit 0. That will be B. Fruit 1 will be A, and so on. So if I go to 5, it will give me the last letter, which is the A. However, if I do f of 6, fruit of 6, Python gives me an error. It says string index is out of range. So pretty much what Python is seeing is seeing a string that is indexed from 0 to 5, which if you count 0, 1, 2, 3, 4, 5, would give you 6 letters. So let's say I want a part of or all of the string. So I can either type fruit, or if I want to use a symbol, it's the column. So And the reason why this column is very important is because let's say I want a specific part. So I want from the beginning until the third letter. So it's gonna give me 0, 1, 2. And one thing I wanna add here is that this index is non-inclusive, meaning that you're actually getting 0, 1, 2. Because if you think about it, if you look at fruit 3, it's actually an A. So it's the A after the N. So what if I want like in the middle? So 2 to 4. So it's gonna give me 2 and 3, which is N and A. And what if I want to get from 3 until the end? So 3 until the end. Yeah. With adding just this without anything after it, this tells you we want until the end, inclusive. However, if we want to let's say count from the back to front, we use as I used here negative number. So negative. So let's say I want to do from 2 to -1, it's gonna be NaN. 2 to -2, gonna be Na. 2 to -3, it's gonna be N. So it's actually very useful sometimes to index from the end, because sometimes you don't know the length of your string, and you're not even interested in finding the length of the string. You just want to cancel the last letter. For example, it's a space that you don't want, or a full stop, or a question mark, or exclamation, or something, whatever it is that you're not interested in finding. So just say, okay, give me everything except the last letter, or except the last 2 letters, or except the last several characters. So it's very useful to know how to index a string. Okay, so the next thing I wanted to show is for loop letter it's an example. So I'm gonna open. So it's for loop. So So the next thing I want to discuss is what is referred to as a for loop. And I think I talked about this a little bit last time, but I wanted to show you the interaction of for loops with strings. So we have a fruit is equal banana. For letter in fruit, print letter. What this is going to tell us, what this is going to do, it's going to consider the string banana, the fruit string, as a list. So it's gonna consider every single character as part of the list, and then it's gonna print. So for example, here it's gonna be okay for letter in fruit, it's gonna be B, then A, then N, then A, then N, then A, and then the loop is gonna end. So let's run this. So this is for let fruit, and enter. It's gonna BANA. So it is printing the different letters in string, which is dissecting it into a list and printing every letter separately. So let's look at the next example. What if I'm trying to count instead of looking at all the letters? Let's say you have a word, you have a sentence, you have a paragraph, you have a book that you want to count the number of N's in it. So in this case, the easy, I think one of the most intuitive ways to do it is to use this for letter in. Of course, there are so many ways, and there are ways that are more efficient, but for now, I think this shows my point, which is okay. Word is equal banana, count is equal 0, For letter in word, so it's gonna go B-A-N-A-N-A, and then I have an if statement. If letter is equal N, so if the letter is N, count plus equal 1. And pretty much what this is equal count, as if I wrote count is equal count plus 1. It's just a more efficient way of writing it, but it's the same thing. And then after it's done, so it's gonna look, and it's gonna go through the whole word and then print the count. So if I do this for count, yes, enter, let's see, 2. Because if you go to this word, it's gonna you have 2 ends. So what if I change it to A? 3, because there are 3 A's. What if I change it to U? It gives me a 0, because there are no U's in banana. The other example I wanted to show yes. So in the first example, I defined banana before the for loop. However, what if that variable fruit, I'm not really interested in defining it. I'm never going to use it again, and I have a sentence, a paragraph that I just want to plug it into Python and see how many letters are in it. So for that, you can actually, for the for loop, you can just say for letter in banana, and it's gonna behave the same way. So again, it's gonna print the letters. So what if I change it to a list, for example? So this actually changes pretty much everything. Let me show you what it does, and then I'm gonna explain to you why. What I did here, and I think we're gonna talk about it later in today's lecture, is I changed the string into a list. And what Python does now, it looks at the list and looks at the different elements in the list and then prints them separate. So I'm not going to focus on it now. When time comes, I'm going to talk about it. I just want to show you that just adding a bracket really changes a lot. The next example I wanted to show is this one. Yeah. So if you have a string, and again, a string can be 1 word, 2 words, it can be 100 words. Because for Python, when it sees a space within a string like this one, for Python, this is another character. It's like A, like B, it's like another character. It's like another letter. So it doesn't really matter. And this is where the inclusiveness. So for example, 0 to 4 is going to be 0, 1, 2, 3. So 0, 1, 2, 3. So it's going to be bore. For this one, it's going to be 0, 1, 2, 3, 4. So it's going to be bored. And then for this one, it's going to be from 8. So on the left-hand side, it's inclusive. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be ME. And I wanted to add something. So when I was counting, I counted the space. So it's 0, 1, 2, 3, 4, 5, 6, 7, and then 8. So we start 8, so it's me, and then the column is gonna print everything. So if I do this, board, me, board. Okay. So manipulating strings. I think when it comes to strings, this is one of the most important things when it comes to strings is manipulation. That's the whole point. Whenever you're reading something using Python, reading a file, reading a book, reading whatever you're reading, a website, you're trying to scrape a website to get some information. A lot of times you're trying to manipulate this string because at the end of the day, books were not written for programs. Websites were not developed for programs. Most websites are not developed for programs. They're developed for human interactions, for humans to use it. And this is why websites and books are not written in Python. They're written in Java, JavaScript, HTML, a lot of things. And what we try to do through Python is go through these documentation and read it, learn from it, and manipulate it so that we get our what we're trying to benefit. So for manipulation, I have concatenation, and I love pretty much showing examples, and this is why you'll see most of my slides are empty. So if we go to concatenation, file, I have these two. I'm going to close these. Yeah. So I did this a little bit earlier, but I wanted to show you an example of how it looks like with and without the space. So good, A is good, B is morning, C is equal A plus B. If we print C, it's gonna be good morning as one word, no spacing, or actually in all cases, whether it's this one, or this one, Python considers it as one string. However, for us as human beings reading it, it's gonna be this, it's gonna show us as one word, and this is gonna show us as two words with a space in the middle. So if I come here and run concatenate, first one is good morning, that's one word. The second is good morning, two words with a space. And I want to emphasize that for Python, these two are the same, not the same. These two are one string. So if you type print type C and then print type C, for Python is going to be the same, class string, and then print C. The only difference is in the length. For Python, this is 11 because it doesn't have a space, and the second one with the space is 12 because it has the space. That is the only difference. The second example. So a lot of times you're looking for if you're looking for something, you want to look for a letter in a string, in a word in a paragraph, a word in a book. You're trying to, and I want to actually talk a little bit about why is this important? Why is that useful? Why would we ever be looking for one word or one letter within a word? Because what and actually this is what Google does in a way. And of course, Google is much more advanced. But for example, I do a lot of I used to do a lot of research, and whenever I'm interested in a topic, I would go to Google Scholar and I would type in a word, and then Google would give me hundreds of thousands, if not millions of articles to go through. And pretty much what Google does is that they use a smart algorithm that finds the occurrences of these words that I'm looking within the World Wide Web, and within milliseconds or microseconds, they provide hundreds and thousands of or even millions of documents that have this word. And pretty much, if you Google anything or you're looking for something, this is what they do. They're looking for the occurrence of this word. How often does it occur? How often is it related? And there's a lot of algorithms that actually pretty much tells you this. They count, for example, like if you type "and" in Google, "and" is or "that," like the these are very common words. However, if you Google it, it's not going to give you everything. Pretty much every article has the word "that" or "and." But if you Google it, it's not going to give you. It's going to give you specific articles or specific websites that are specifically talking about "and" "that." And the reason this is the case is because they're not just looking for the occurrences of these words. They're looking for what is referred to as the there's an index, which is pretty much weighing the occurrence of this word compared to other articles and looking at the focus. So long story short, looking within a string or within a document is very important and very useful. And whether or not you know how it works, you're actually using it every time you're visiting the World Wide Web. So for this fruit, I named this apple, and this what I'm doing here is I'm testing. I'm saying, okay, this is like me saying, is is the letter A in fruit? And Python is going to tell me whether this is a true statement or a false statement. And the same thing here is the letter B in fruit. And the benefit is that I can actually look for several letters together. So is PPL in fruit? And and then I'm saying, I'm adding another if statement. If A in fruit, so if this sentence is true, print found. And then I can say else print not. So if I run the concat2, so is A in fruit? That sentence is true. Is B in fruit? That sentence is false. Is PPL in fruit? That sentence is true. If A in fruit, if this is a true statement, print found it. If not, print it. So what if we change this to B? So everything is the same. However, when we go to the if statement, if B in fruit, this is a false statement. And then it goes to could not find, and this is what we get. And in practice, there's a lot of things we do sometimes to prevent errors. So for example, this is printing, so that's easy. But let's say I say I incorrectly index a word. For example, I say fruit 10 or 20. Then I say x is equal to fruit 10. If I run this, it's gonna give me. So it's gonna give me. It's gonna solve everything because it goes in order. So the first thing that Python does, it checks the script. Are there any syntax errors? So let's say if I do this, and I run it, it's not even gonna run because pretty much Python is saying that there's looking at the code and seeing an invalid syntax, so Python doesn't run. The second thing, if there is no syntax error or if there is no error in writing the code, what Python does is that it runs the code sequentially, so line by line. So it does this, and so on. So if I do this, it goes true, false, true, could not find B, track, and then it tells me, oh, like this is a mistake. Like you're using a string syntax index out of it. In practice, usually when we do something like this, we use the try except method. And I think I talked about it last time, but I want to show except print index not found. So if I run this now, it's going to tell me index not found. So it's going to run. It's going to try this line that I put for it. And then it's going to tell me, look, index is not. And whenever, this is actually very common, especially like, let's say you are applying for an email or applying for Facebook, like making a new account, registering for Facebook. And whenever they ask you for your date of birth, and if you write your address or your name, the website is going to tell you, look, this does not make sense. So instead of crashing, the website is telling you, look, you need to fix this. This is not what I was expecting. I'm expecting a number, for example, and I'm getting a word. I'm expecting something, some sort of format, and I'm getting something else. So a lot of codes, and not just Python, a lot of languages use this try except method. Okay. Let's move on. So string library. I mentioned that there's a lot of string manipulations that we can do. And actually, when it comes to strings, Python can do so much. So for example, these are just examples. So greeting, hello, or greet, hello there, greet that lower, as you would expect, it pretty much changes everything to a lowercase. So let's see on CFD. So if I say greet is equal hello there, let's say greet 2 is equal greet dot lower, print, if I print the original word, it's going to be the same, print greet 2, it's going to be hello there, all lowercase. If I change it to, if I want to print greet 2 dot capitalize, it's going to capitalize the first letter. And there's strip, there's find, there's replace. So strip. So let's say if I have a string, let's do this. Greet 3 as I want to add. I'm going to add a lot of spaces. So if I print greet 3, I'm going to get all these spaces. So you compare this to this, I'm going to get them all. So in Python, there's a way to strip the space on the left. There's a way to strip the spaces on the right, and there's a way to strip all the spaces. So the first way is if I wanna remove all the spaces from the size, I'm gonna say print greet 3 dot strip, and you can see it removed the space here and here. And the reason why you can't really tell the space on the right because it's then and all is black. However, if I do I want to do R strip. R strip is going to just remove the spaces here. So this stays the same. What about L strip? So if you do strip and L strip, they look the same. However, they are completely different strings. And the way I can do this is if I say greet 3 or greet 3 R strip, I'm naming is equal greet 3 dot R strip and greet 3 R strip is equal greet 3. So instead of I want to do L strip, actually I'm trying to compare the L strip with the strip. So for this one, I'm just gonna say strip, and I'm gonna print the last two. So print greet 3 L strip or R strip. Actually L strip, and print strip. So these look the same. However, if I say length, greet 3 L strip is gonna be 18, and if I print just the strip, it's gonna be 11. And even though we can't see the difference, there is actually a lot of space here that 7 spaces here that Python still considers. It's still using part of the memory. Okay. What about find? Uh, so greet. So greet 3 dot find and then H. Okay. So the reason, so what I'm asking Python here, I'm asking Python to give me the location of the letter. So what it does, goes to greet 3, which is this one. It counts the number of spaces, and then it finds H as the fourth element. So let's change it to strip so that we know we can be easily be able to count it. Yep. And this is, I want to show you the string that we're dealing with. So hello there, no spaces at the beginning, no spaces at the end. And if I want to find the H, it should be 0. If I want to find the L, it's gonna be 2, 0, 1, 2. And um, the find looks for the first occurrence in a string. So here you have 2 L's, but it finds the first one. It's like, okay, I found it. Here it is. There are other functions that can count how many occurrences you have, but for this one, it looks. Another very important one is replace. So let's say I want to change this O, or let's say there's a typo. So um, greet 4 is equal hello there. If you print it, there's a spell. There's a type, and I want to change that type. So I can come here and say, okay, print dot replace. I'm going to say U with O. So the reason why there were 3 dots, because I did not close this bracket. So for Python, it sounds like there is something missing. So if I go here, changing the O in hello there to the U into an O. Okay. What about if I want to change the L? So L to I. I'm gonna change all of them to both L's to I. But the question is, okay, so why did it not why did this not stay? And the reason, because we never created a new string. We're doing greet underscore 4 dot replace. So we are just printing what this looks like. Um, we're not actually creating a new variable. Okay, so these are some of the uh, functions. However, there are so many more. And if you want to know all of them, you write dir and then a string. It can be any string, and it shows you everything, everything you can do with that string. So these are a bit using them is a bit different. So if you have like underscores, however, you can see this is. I'm trying to. So you have rjust, rindex, split, rfind, rstrip, upper, translate, title, find, like everything, all of the ones I used and others will be in the direct dir. And dir is actually a very general function that whenever you're curious to know, okay, how do I write this? How do I write strip? Is it strip or strep? You just do direct dir and then string, and then it's going to give you all the functions that you can use. Upper. So this is where it's where a lot of what we've been discussing converges somehow. Whenever you receive an email, Google, Gmail or Yahoo Mail, whichever you're using, or Hotmail, they look at the website reads your email. It reads it. It goes through it, and then it looks at the sender from to, and it determines, okay, the most common thing that they do is this email spam or not. looking at this information, is it specifically for you, or is it sent to hundreds and thousands of people? This is the first thing. Does it look sketchy? Does it look like someone is trying to steal your money, steal your identity, have a virus, malicious file within the email? So they look at all this. So actually, the Gmail or Yahoo Mail or Hotmail, they have a software that goes through this. It's not a person that goes, of course, over millions and millions of emails every day. It's a software that goes through it. And what this software does, one of the things it does, it parses the email. And what I mean by parses, it takes a chunk of email and then splits it into words or sentences. And then it reads it. And because it's a smart code, it actually understands what it's trying to do. So it looks for typos. So it compares what's written to the English alphabet. It compares it to the dictionary, compares it to words to see, okay, is this a typo? Are there typos? Was this written by a person, or is this written by a robot? Are there anything which? So pretty much parsing is one of the basic functions of Python, and it's very useful and applied in a lot of languages and applied in a lot of applications. So if I look at the examples that we have, so parsing. Here. So for example, I have this string from my email, Thursday, October 5th, 2021. So what I'm trying to do is I'm trying to get what is the host name. So what the host name, I'm referring to the tamil.edu. This is the host name. Okay. So, but if I ask Python, okay, please give me the host name, Python has no idea what I'm talking about. For Python, like, I'm seeing a string. You can tell me find a character. I'm going to tell you where it is. So from my knowledge, I know, okay, every single email has, let's say every single email has this from person, the email, date, October 5th, and then the day, the date, and then the year. So month, day, year. So I know that, okay, if I want to get the host name, what I can do is, okay, I can look for the @ because I know from my experience, domain knowledge, is that there's only one @ and it's going to be at the host name. So it can be find @. So it's going to give me the position of @. And then I'm going to be like, okay, find the space after @position. So this comma @position, I'm telling, because if I just say find space, it's going to look, okay, and then, oh, I found the space, and that's it, I'm done. But this is not the space I'm looking for. I'm looking for this space, and I'm looking for this @ so that I can get this. So what this does is I'm saying find space after @position. So what is @position? It's this @. So it's gonna start looking from here. It's gonna look, okay, no space, not space, not space, so on, okay, and then I found the space. So it's gonna find this, and then it's gonna print this for me. And then I'm gonna say, okay, the host name is whatever is in between this, between the @position and the space position. And the reason why we're having +1 is because, as we discussed earlier in strings, the first part is inclusive. So if I don't have the space, it's going to take into account the @. So it's going to be @tamu.edu. And we also know that the space, the last part of the list, is non-inclusive. As a result, it's going to be without it anyway. So you don't have to do -1 or. And if we actually want to include it, we have to do +1. So let's see how this code works. So the location for the @ is 13. So let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it says 13. And the space after the @ is 22. So 14, 15, 16, 17, 18, 19, 20, 21, and 22. So that is correct. And then position +1 stem mode. So what if I want to keep the at and just read this? It's going to be at tab. And this is how we parse text. Of course, there are much more intelligent ways and much more complicated ways of doing that. However, from my personal experience, I believe that if you don't understand these simple methods, and sometimes using these simple methods are the best way of actually parsing a string. If there is consistency within your text, I would always recommend using these simple methods instead of having to go, because if you go online, you can find very complicated scripts that does great parsing. However, a lot of times it's not necessary. So look at your application, understand your text, and from that, build the parsing code. And one thing I want to add is in general, whenever you're parsing, there has to be domain knowledge, meaning you have to know what you're reading. You have to have some knowledge of what you're reading. If you give someone who has no idea, so let's say it's a different language, Mandarin or Japanese, and for example, I don't speak either of these languages. So if I go and I'm trying to parse these languages, I will do a horrible job because I do not understand this. However, if it's English or Arabic, I can go through it. I can understand. Okay, this is what I'm looking for, and this is how I can benefit. Okay, so we've been talking about parsing, paragraphs, words, lists, strings, but in a lot of times, what we are trying to actually understand or read is a file. It's a file that can have hundreds of thousands of words, millions of words, and we are trying to take this file, it can be a book, and reading it and understanding it through Python. So for this case, I actually created a file. It's a very small file, which is called hello, and it's just hello world. My name is Abdelrahman, and that is it. So let's look at the code that I wrote for it. So okay, so the first thing, in order to open the file, you either change directories, but because this file open is in the same as hello, I don't have to tell Python, okay, go to this directory. It knows it's the same directory. Open file. Okay, print file. So let's see what happens if I use. So open. And when I say print file, you'd expect, okay, Python is gonna print the file. However, what Python is doing, it's telling me, okay, what you're asking me to open is a text IO wrapper. Name is hello text. Mode is R, which is reading. Encoding is CP1256. So pretty much what Python is giving me is the properties of this file. And for me, this is not relevant. I'm not interested in this. I'm interested in actually reading the file. I don't care about how Python is reading it. I'm caring about how I, as a human being, can read it. So let's see what we can do about that. So for that, I'm going to open the file. So the first thing I'm going to do is I'm going to count how many words it's in it. So files are treated somewhat as a list. So what it's going to do, it's going to look for words in the file, and it's going to count them. So if we count them, it's going to be hello world 1, 2, 3, 4, 5, 6, 7. So let's see. So what this is actually doing, and I intentionally did this because for word in file, it's not actually looking for word. What Python is doing is looking at a line by line. So this is a poor choice of naming. So this should be for line in file count plus equal 1 print line. Then it's gonna make more sense. Number of lines, because it goes into, this is the file, it goes, okay, 1, 2, 3, and it prints the number 3. Okay. But this is good. Okay, so okay, this is important if I, or useful if I want to count the numbers. Right? But usually what I'm trying to do is I'm trying to get into the words themselves. And for that, open 3, and this is the function that I have to use to actually read this text. So it's going to be file.read print imp. So if I do 3, it's actually reading. In general, this is not good practice, since a lot of times you actually do not want to read all the file at once in memory. Because imagine having a file that is gigabytes in size, or even terabytes in size. If you try to open this, what Python does, it takes this file and puts it on your RAM, random access memory. And usually RAM has a much smaller storage. It's like 4, 8, 16 gigabytes. So it's like the maximum I've worked with was like 265 gigabyte, and that was like a huge computer. Like it's not normal. Usually it's like 64 at maximum, or 32. So imagine opening a terabyte file on a 32 gigabytes RAM. It's gonna crash. It's gonna tell you freeze. So in general, we don't use this function. However, for a file when I use, the size is like 1 kilobyte, so it's not a big deal. Okay. So let's see. Do I have? So lists. So now I want to define certain meanings and address what are lists, how we can use lists. And actually, this is one of the most common data structures that you're going to work with, because they're easy, they have a lot of benefits. So an algorithm is a set of rules or steps used to solve a problem. So what I mean by algorithm is that if I ask you, okay, how, if I want to change a word in a text file, how would you solve this problem? So you tell me, okay, the first step is you need to open the file. The second thing is read the lines, and then read the words, and then look for the word you're looking for, and then change it. This is what I mean by algorithm. So I guess it's the coding that you're gonna do, but in words, the steps that you want to follow. And then data structures are pretty much a particular way of organizing data in a computer. So, for example, data structure is a list. A list is, as the word implies, it's a set of, it can be numbers, strings, or it can be a combination of both, just put together in a list. There are also dictionaries and tuples. However, these two, I'm going to talk about them next week. So if for example, x equal 2, this is a data structure. Countries equal Egypt, UK, and India. This is a list. And we can actually make a list of lists. So Egypt, so for example, country's capital, Egypt, its capital is Cairo, UK, the capital is London, India, New Delhi. So let's see how we can. So show lists, and lists are immutable. So lists are mutable. And this is actually a very common word in Python when we say, okay, this is mutable or this is not mutable. Mutable meaning we can change it. We can remove something, we can add something, we can change something. Mainly the changing is what defines a mutable thing. So, and I'm going to show you examples. So let's look at lists. So yeah. file. So in this file, we have countries equal Egypt, UK, India, capitals. Okay. So if I want to look at this list, and I'm looking for one, it's gonna be okay, 0, 1. So it should give me UK. Capital countries 0. So it's gonna give me Egypt, Cairo. But what if I want to go within a list? So what I do is okay, country 0. So this is gonna be Egypt, Cairo, and then I want the first element within that list, which is gonna be not the first, the first, like the one index word or element, and it's gonna be Cairo. So this should give me Cairo. Let's see. So list and index in 1, UK, Egypt, Cairo, Cairo. This is what we expect. Okay. I mentioned that lists are mutable. And what I mean is we can change it. So here is the first list. Countries. Egypt, UK. I wanna remove India and put Italy. Or actually I'd rather remove UK, this is a European country, and put another European country, which is Italy. And for the second list, I'm going to remove the whole second element, which is India, New Delhi, and I'm going to put Brazil. And someone can ask or can be curious, okay, then, but how am I going to remove a list and put one element? Python doesn't really look at this as a list. It looks at it as an element in the list. So it doesn't matter if it's a list, if it's a list of lists. So let's say this was actually like a rabbit hole of lists, like 100 lists inside each other. Python doesn't really matter. They look at this as element 0, element 1, element 2, and then okay, I'm gonna replace element 2 with Brazil. So this is all gonna be removed and it's gonna be Brazil. So let's see how it looks like. So for this one, it's supposed to be Egypt, Italy, India, and for this is gonna be Egypt, Cairo, UK, London, and then Brazil. So we removed UK, put Italy, Egypt, Cairo, UK, London, and Brazil, as we expect. The next thing I want to talk about is list manipulation, and this is actually there is a lot of nuance to that, and I'm going to talk a little bit about that. So list manipulation. Let's close this. List manipulation. So the first thing I wanted to do is adding lists. So you can expect that okay, 1, 3, 5, 2, 4, 6. So it's gonna be 1 plus 2, 3 plus 4, and 5 plus 6. And that is actually not what Python sees. When there is a way, of course, to do that. However, when I just say add a plus b, it's gonna be 1, 3, 5, 2, 4, 6. Let's say list. 1, 3, 5, 2, 4, 6. The second thing I wanted to show you is the directory or everything you can do with a list. I already showed you this when it comes to strings, but I also wanted to show you when it comes to I showed you with strings, and I want to show you what it is like with lists. So append is a very useful function. What it does, it adds an element to the list. Clear, it clears the list. Copy, count, gives you the number of the list. Index, insert, pop. Like you can sort the elements in an ascending order. So all of these are very useful functions. It's always good to do DIR whenever you're working with something new and trying to understand it. So if I want to create a list, I can say A is equal list, or I can say, or I can create something like this. And if I say print type A, print type E, they should be identical. So let's remove these and see. Both of them are this. So these are two ways of creating a list. So what if I created an empty list and I wanna add things to it. So what we do, we use the word append. So a dot append apple, a dot append 9. So if I print a, it should be apple and 9. And as you can see, Python recognizes that these are different types, meaning that apple is a string, while 9 is an integer. And you can combine different types of elements within it. Another thing I wanted to talk about was pretty much a lot of functions that are very useful. The first one is length, len. It gives you the length. So you have 1, 2, 3, 4, 5, 6. So it's similar to strings, that it counts the number of elements. And then max, min, sum. Max, what max does, it gives you the maximum number. What min does, it gives you the minimum number or the smallest number. What sum does, it adds all the numbers. And finally, sort. By default, sort is ascending order. So if you do sort, it's gonna be ascending order. So if you run this code, you get first thing is length, it's 6, 0, 1, 2, 3, 4, 5, 6. Maximum is 5, minimum is 1, sum is 15, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. And then sorting is 0, 1, 2, 3, 4. And there is a way, if you want to sort it in a descending order, you just add you add something within sort. Give me a second, I can just check it. Okay. So, or if I wanna reverse it, so I can do what I can do is I can say reverse equal true, because by default the reverse true, and print a should save it. So I sort a dot sort, it's in an ascending order. A dot sort reverse equal true, we'll change it to descending order again. Okay. So the last slide that I want to talk about today is lists and strings. And for that, create 3 files. One of the, as I mentioned again, and again, one of the very good things about Python is that there's a lot of smart things you can do with text. So for example, I am testing this. This is a string. Python looks at it and says, okay, this is one string. Doesn't matter that it's 4 words, but we read it. I am testing this. So these are 4 words. But for Python, this is one word. However, if I want to split it, so what Python does when it says split, it actually looks for spaces. And so it knows the English language. and it knows that you separate words using a space. So it looks okay. Then it's like, oh, it's I am testing this. So these are 4 words. So it's gonna change this actually to a list. So from a string, it's gonna change this to a list. Let's see how it works. String 1. So this is I first printed the string and then the words. So this is a string, and then it changes it to a list. And whenever you're actually working with a string, with a file, with a Word file, most of the times you will have to convert it to a list in order to work. Because there's a lot of things you can do with a list that makes it easier to understand what you're reading. Okay, so but what if I had like 100 spaces or 1,000 spaces? Is it going to look at every space and consider the space a word? The answer is no. Python is smarter than that. It's something like it does something similar to strip. So pretty much it removes the spaces completely and be like, okay, I am testing this, and this is a word. These are the list of words. So if I do this, 2, again, even though the string has all these spaces, whenever it's converting it to through splitting, it gives me the 4 different ones. It's the same. So, and this is another benefit of converting string to list, that it gives you a more consistent response. Okay, so what if I don't want to split using space? What if I have a list that are separated by, or I have a string that is separated by columns or semicolons or full stop or comma, or instead of me wanting to get the words, I'm trying to get sentences. So I want to know each sentence that is separated by full stop, or I'm trying to get the questions, which is each one is separated by a question mark. How do I do that? And it's actually very simple. So if you have the string that is separated by columns, and I want apple, grape, fruit, I can just say split using this character, which is a column. So in this case, the sentence would be the same. However, words would be apple, grape, and fruit. So I'll come here, apple, grape. What if I add space? What actually Python is going to do, it's going to keep the space, because for Python, they're only separating here based on the column. So if I save this, it's going to consider the space part of the list. So be careful with that. And a very common thing that people do is that sometimes if you have a problem like this, the first thing is that they remove the space. Say, okay, remove the space completely. I don't want to see, I want to replace the space. So let me show you what I would do. This. I'm going to be sen is equal sen dot replace space with nothing. So, and then do this. So let's see what is going to do. So pretty much what it does, it removes all this space and put it as nothing, and then it splits. And then if you look at the sentence, so let me do this. Send to, so that you show that I show you that it is still the same. And let's keep this works too. I want to show you that they will stay the same. So the first one, whenever I split it using the columns, it keeps it. And then if I replace the space with nothing, this is going to be the list. And then if I separate this list using columns, I'm going to get apple, grape, and fruit. And I think this is the end. Yes, this is the end of today's lecture. I hope this was I guess more informative than last time. This was the intention. I also hope that things were clear with the command prompt, and I know some people could not see, so I made sure that the text was larger this time. And I will hope to see everyone next week. Fatima, are you still here?
Okay, thank you, Doctor, for this informative lecture.
Mariam, so-
We have some questions for you.
Sure.
So the first question is that how can we select an element from a list in Python?
How can we select an element or a list of Python? Okay, so let me show you. So let me, can I share my screen again?
Yes, sure.
So if we have a list, A is equal, so I'm confusing language. This is MATLAB. Okay, so A is equal 1, 2, 3. Actually, let's keep it words. Test, quiz, homework. So the question is how can I pick an element within the list? So if I want to pick quiz, this is indexed as 1, so it's going to be A1. If I want to pick homework, it's going to be A2. And test is going to be A0. If I want to pick a range of elements, it's going to be let's say 0 to 2. This is going to give me the first two elements, 1 to 2, or 1 to the end is going to be quiz class 2. So this is how you pick elements within a list.
Okay, thank you, Doctor, for your time. To highlight, this session has been recorded and it will be uploaded soon on Arab Gur's YouTube channel. Now, the first lecture will be uploaded today. We apologize for the delay. Now, that's all for today. I hope you enjoyed the session. Have a nice day and see you next Tuesday.